statements that go with a conditional statement. So we talked about a conditional, we talked about a converse, we talked about an inverse, and we talked about the contrapositive. We talked about how to find the truth value of each one of those as well as a negation, which kind of goes into it. Negation is the only one of those that's not its own if-then statement. All the others are written in if-then form. So today we're going to talk about a fifth if-then statement, which we call a biconditional. So if we break down the word biconditional, what does the prefix bi mean? Two, right? So what we need here is we need two statements to basically form together to make a new one, okay? And it's going to be two statements that we used yesterday. And so when we put a biconditional together, the two statements that we're going to use are going to be the conditional and the converse. Okay? Those are the two that must be true. Okay? Both of those must be true. If they're both true, then we are going to combine those two statements together with the words if and only if. Okay? And I'll show you how we're going to do that. The symbol that we use for this is P implies Q, Q implies P. I kind of think of it, I call it a two-way street, right? Because it goes both ways. Both of them imply each other. And it goes both ways. The way that we would read that is P if and only if Q. So the statement that we're going to use is the if and only if part. Now, I'm going to tell you this, rather than writing out if and only if every time, I always abbreviate that as IFF. Okay? And it's just the abbreviation that I use. You won't see probably like the textbook use that or Big Ideas use that. That's just kind of something personally, so you don't have to write out if and only if every time we do it. Because all the problems that we're going to do today are going to be biconditionals. And we're going to have to write if and only if every time. So if you want to shorten it, especially when you write it out by hand, you can do IFF if you want to. Okay. We're going to rewrite the definition of perpendicular lines as a biconditional statement. First of all, the conditional. This is just a statement. This is just a definition that we're given. Two lines that intersect to form a right angle are perpendicular lines. So that's the definition of perpendicular lines. Okay? So we're going to write that as a conditional statement. We're going to put the words if and then in there, like we did yesterday. If two lines intersect to form a right angle, then they are perpendicular. I'm just rewriting this statement, putting it in an if-then form. Okay? Now, if we write the converse, and here's where we were talking about what words go where, that's sometimes a little bit tricky. Okay? The two things that are going to flip-flop are forming a right angle and perpendicular. Okay? I'm going to keep the two lines in my first statement. Because if I just said, if they are perpendicular, I have no idea what I'm talking about, right? So the two lines has to stay in the first part of our converse. So we're going to take the statement and we're flipping it around. The P and Q are going to replace each other. And we're going to say something like this. If two lines are perpendicular, then they, thank you,
Thank you.
intersect to form a right angle. Okay, and we talked a little bit yesterday about perpendicular lines. Okay, and so if two lines intersect to form a right angle, then we said yesterday that they are perpendicular, right? That is the definition. So typically, if you have a definition, it can be rewritten both ways, okay? And so that's what makes it a good definition, is I can interchange it and it still means the same thing, okay? I'm just drawing a picture here so you can look at it and say, yep, okay, here's what perpendicular means, here's what it looks like. Those two lines form a right angle, so they are indeed perpendicular. If I tell you those two lines are perpendicular, then they must form a right angle. Okay, so either way I go about it, we know that that's a true statement. So my biconditional, we're going to combine these two together, and we're going to form a new statement. This is the one we haven't done yet. We're going to get rid of the if and the then. And typically what I'll do is I'll just go back to the original statement, the conditional statement. Okay, and here's how we're going to start it. I'm going to get rid of the word if. I'm going to say two lines intersect to form a right angle if and only if, that's that new part right there, and I'm going to let you shorten it, IFF, if you want to. If you want to write out if and only if, that's fine, but I'm letting you shorten it if you want to, because we're all about doing some abbreviations here. If and only if they are perpendicular. Okay, and that is our biconditional statement. It's true either way, okay? And that's what makes it a biconditional. No matter how I say it, it would be true either way. Okay, let's look at the next one. A shape with four sides is a square. Okay, that's the definition that's given to me. What we're kind of trying to decide here, is it a good definition or not? Okay, if I can write a biconditional with this, then that's a pretty good definition. And if I can't, then it's not a very good definition. Okay, so a conditional, if a shape has four sides, then it is a square. Okay, and I know yesterday when we talked about the truth value, we waited till the very end to determine truth value, but we don't want to do that today. Okay, and the reason why is if either one of these are false, I'm not even going to make it to the biconditional. Okay, so we're going to look at the truth value as we go. And I didn't necessarily talk about that up here, but both of those statements were true. Okay, in this case, if I draw a figure that has four sides, is it always going to be a square? No. Okay, what would be an example of something that's not? A rectangle, right? A rectangle doesn't have four congruent sides. Okay, a parallelogram. Okay, I could draw a figure up here that doesn't have any sides congruent, right? Doesn't have any right angles. Still has four sides, but it's kind of like all over the place. So this is a false statement. And you could even draw like a picture, like I just did, and draw a four-sided figure that's not a square. So do I need to write the converse? I don't care what the converse says, right? Because already we're saying this is not good. Okay. In order to make this a better statement, what other information would need to be added in there? Okay, equal sides, 4 equal sides. Okay, would 4 equal sides get it done? Close. One other thing. What else do all squares have? 4 right angles. Yeah, so we would need to say 4 equal sides and 4 right angles. Okay, so we're just missing some information. So that would not be a good definition of a square. If somebody didn't know what a square was and you said a square has 4 sides, that wouldn't describe it very much. Okay, if I was trying to describe an airplane, I wouldn't say an airplane is something that flies. It's true, right? But I would need to get it, because if I look up in the sky and I see a bird, I'm like, oh, that's an airplane, right? It's not true. So we got to be more descriptive. If biconditional is basically a definition of something. Good morning. Okay. Rewrite the definition of a right angle as a single biconditional statement. So we're not going to write both of these out, but we're going to verify that we definitely can. If an angle is a right angle, then its measure is 90 degrees. True or false? True. Okay, all right angles are 90 degrees. If an angle has 90 degrees, then it's always a right angle. True. Okay, it works both ways. So we have to state it both ways. If we say yes, it works both ways, then we say true, and then I can rewrite this and I can say an angle is right if and only if its measure is 90. Okay, here's another one. If 2 line segments have the same length, then they are congruent segments. Okay, so if I said, here's 2 segments, this one has a length of 3 and this one has a length of 3, then are they congruent? Yeah, because what's it mean to be congruent? The same. Okay, they have the same length. Okay, if I tell you that these 2 segments are congruent, then do they have the same length? Does it work both ways? Yeah. Okay, we want to state it both ways. We want to flip-flop it, make sure it's true both ways, and if it is, then we will say 2 line segments have the same length if and only if they are congruent. Okay. What we want to look at down here, we have 2 separate statements. Neither one of them are really geometry related, right? But we're trying to decide, can we take all this information and put it together to make a biconditional? Okay? So what they should have here is they should have something in common because of 2 separate statements. If Mary is taking a theater class, then she will have to be in the fall play. If Mary is in the fall play, then she must be taking the theater class. Okay? Are those statements the same thing? Okay? Or can we write it like this? If Mary is in the fall play, then she must be taking a theater class. So what they're saying is this school says if you're taking this theater class, you must be in the fall play, and vice versa. Okay? So only people in the theater class can be in the fall play, is what we're saying here. Now that wouldn't be true necessarily here, because we don't necessarily have a theater class for the musical that we did last week. Mary is in the fall play if and only if is taking theater class. Okay, both of those statements were true, or they're stated as true, so we know that it has to make a biconditional. Hey, the next one. If you run for president, you must be at least 35 years old. Okay? Did you guys know that is a requirement of being a president? Got to be at least 35. Maybe heard that one before. Okay? If you are at least 35 years old, then you can run for president. Okay? Same exact statement, just flip-flopped. Okay? But that is, yeah.
The second part isn't true because there are some other things that can disqualify you from running for president.
Right, but do you have to be at least 35? Yes, and you're right, there are other requirements of it, but in order to run for president, do I at least have to satisfy this? And if I am at least 35 years old, then can I run for president?
Only if you meet the other conditions.
Right, I'm with you, okay. So you can, doesn't necessarily mean that you will, or that you meet all those conditions, but you could, you have that possibility. But yes, you got a lot of conditions that would have to be met. So we will say something like, you can run for president if and only if you're at least 35 years old. All right, that's all we got, guys. Okay, pretty short lesson today.